You guys all ready? Sound is good? Do you hear me well?
Yeah, great.
Okay. Video, everything? We're good? All right. Awesome. Well, welcome early in the morning. My name is Daniel. This is the first workshop of the day at DappCon. Super happy to be here. I hope I can get you excited about the stuff that I'm talking about today. It has a long title. I actually decided to keep it a bit more simple. So I wanted to talk about deploying your application once and using it everywhere. The original title was Crossing the Interoperability Bridge, a deep dive into building interoperable dApps with IBC. But one big, I guess, message I want to bring across today is that we're building a lot of really deep core technology, but in the end of the day, we really actually want to keep things simple. So I'm the CPO at Altiplanic. This is the core contributing company to Evmos, the Evmos Foundation or the Evmos chain. Has anybody heard of Evmos here before? Okay, quite a few, okay, majority, yeah. Yeah, Evmos, maybe for the people that are not aware, is EVM blockchain, layer 1. And I could explain a lot of things about, I guess, the like compatibility with like the Ethereum client and everything. But the main things to remember or to really understand about Evmos is that we're building the innovation to really connect applications on several blockchains to really foster interoperability between different protocols. So we've been, initially we built Ethermint, which is the EVM library that has been forked over, I think, 290 times now. There's multiple chains actually using this library as their settlement layer and building entire DeFi ecosystems on it. There's, like things like Crypto.com, Kava, Kanto. There's a bunch more, and obviously also Evmos that are using this technology to build applications. And we really see like more, like basically for us, like the real big future and what we've been observing is that there's more and more technology coming out and the types of chains and architectures are really diversifying. However, the EVM for us has been really the primary and like the most used, I guess, application or layer for developers to build on top in a permissionless way. And so we really think that we want to simplify things, and I'll go into this topic a bit more, and I'll also run through a demo of how you can actually deploy these kind of contracts and build an application that's, you just need to deploy once on one chain, but then it's used from anywhere, from any other chain as well. And before we get into this, like one thing I want to start with is really this idea of, probably everybody here has been already working in crypto for a while, building maybe protocols, applications. You probably have some friends or family that you've been trying to like get in early into this new like system of values and decentralization. But like I find it still also personally incredibly hard to really convince people that, or like people that don't really have anything to do with crypto and blockchain, that this can be the new future, or already is. And so you might find yourself, encountering this situation that you already see, the danger coming, and you're trying to take all the people and are your friends with it, and trying to get them in on this ride early. And what I want you to imagine is that, you're actually working in crypto, but you don't really try to use too many technical words to really convince other people of the values of it. So we have things like wallets, networks, RPC, MEV, data availability sampling, like zero knowledge, all these things that are super interesting and obviously really important to discover like the next technological advancement and make things easier. But when we're actually talking about it, it's really about keeping it simple. And so that's why I want to give a bit more like a simpler introduction to this. And what this actually means, or actually, I mean, coming back to it, like obviously we're still working on all these topics, and they're incredibly important. But when you're explaining your your application, even in like Web 2 projects like Uber or Airbnb, you're not really concerned with the database that's underlying when you're telling somebody about this product, right? And before, I started my journey in crypto also as a core protocol engineer, but before I was working in product in Web 2, and so now I'm working again in like more the product side, where I find this is really important for really adopting more users. So what I really want to simplify this to is that when you're building your applications, I want you to think about, there's a user that wants to do something, there's some kind of intent, it's pretty simple, right? And they get something back, that's the result, that's how you want to actually pitch your product. And there's something in between that's happening. And for the developer community, it's obviously important, but that's the simplicity I want to get to, and that's how I think we'll also be able to convince people to use our products. They're just more concerned about, like what they can get out of it, right? Maybe it's an investment, maybe it's hedging their risk. They're maybe financial, most of them probably financially interested, but maybe also they just want to have fun. Or they actually connect to the values that the developer or the community is building, and that's why they're using your product. So if you think about building a new application, try to really think big picture first and abstract it in this kind of way. And obviously this word intent has already been used a lot now for more this kind of like the user is requesting or making some kind of a demand, and then there's maybe different like actors trying to fulfill this demand, but it also becomes quite technical. But that's kind of the way that we think about it on a high level. So one of the observations we make right now is like, why are there so many chains, right? So if you look at the most like, I guess like the blue chip applications out there, like Aave for lending or Curve as a DEX, like what you'll find is obviously this big drop down of a bunch of different chains. And I want to really challenge this, and at LT Planning and Evmos, we really want to challenge this and say, well, why from an end user perspective is there this drop down really necessary, right? On the background, you obviously know like there's these teams deploying this application on multiple chains with individual liquidity, which might also be fragmented, and as well as like different maybe wallets or onboarding experiences. But that can be very overwhelming. And from the way that we use applications, at least nowadays, as an everyday user, you're not really able to make a decision here, okay, which is the best chain to use. And you probably shouldn't be. It's really not really the end goal, as we find. And so there's two major problems that we observe at the moment that I want to get more into. So the first one that we see is that onboarding users is incredibly hard, right? Like if obviously like you can explain to somebody or go through some docs to maybe set up your wallet on Ethereum or any other chain, but if you have to think of like having to do this for 8 or 9 different chains to really also manage your wallets, it can be quite overwhelming. So why do we actually need this? And so I think this is a challenge that we really need to overcome and think of it in a way that you only want to onboard a user once to like having an account, the notion of an account or a wallet or an address. Even like using these kind of terms is actually super important, right? So what we did, for example, as a first step, and there's obviously many more, not just on Evmos, but what we did is build such a like an onboarding guide, which we called Copilot. And I'll play this little video here. Basically, it's just is like a widget to like help the user onboard to MetaMask or Kepler, and then create their wallet. And there's some like fun things here built in there, but it also lets you onboard or like on-ramp with either like fiat or crypto. And the idea is really like trying to abstract all the crypto wording away. So if you even like look at like simple things like in the UX, if you look at the connect button, usually like many applications have connect wallet on it, but having just connect, sign in or things like this make a big difference. And So the idea really for like onboarding users is like the goal should be you should be only onboarding them once to have some kind of idea of a wallet, of some kind of account that they hold their assets in and can interact with or identify themselves. Obviously, for security reasons, you might simply, similarly as you have it with your normal bank accounts, you might have several ones because of, you want to diversify your risk, but we really want to get to that parity. The second big problem that we see with this, like why are there so many chains, is really this idea of mercenary, like multi-chain capital, where we have really more like, I guess, successful applications, like widely used applications popping up, and like originally starting in Ethereum, like DeFi summer, and they, obviously they're also opportunistic and try to deploy to as many chains as possible, maybe even getting paid for it, but like basically you're deploying the same code on several ecosystems. And so what we here see is, this, or what we actually want to see and what we're building towards is shifting this idea of a multi-chain dApp strategy to a cross-chain dApp strategy. So if we take the example, for instance, of Aave, like we saw before, you could have the Aave protocol for lending be deployed on several chains at the same time. This causes, you have to also maintain the different upgrades or kind of take part in maybe like understanding what's happening, and you have different liquidity and liquidity pools everywhere, but it really is more like a redundancy, and it creates this idea of like it's not really scalable. That's the point. And so what we actually are building towards with like the EVM on Evmos is this idea that you'd only have to deploy it once, either on Evmos or another EVM chain, but then you can really access this application cross-chain from other networks, from like other accounts. And so you'd only have to really maintain like one interface, one API to interact with this application, and but still be able to, like access different chains. So those are kind of like the two, I guess, major problems that we see. And if we solve them, what we actually see in the future is, two specific things. And I wanted to give some examples, which we call omni liquidity and I guess omni NFT. So if we run through like stories, like, yeah, you can borrow something, like borrow assets without really knowing from where. You just like trust the protocol based on, other users and the verification of the contracts. And you could say something, well, I want to use Aave to borrow some Atom with ETH. But the important part in this story here is that you don't really say where it's from, right? The chain is not really part of this sentence. And so that's how we kind of are thinking about, building new applications. And the same thing with NFTs. Like one thing you could say, I want to buy a BadKit NFT. If you're familiar with these ones, they're pretty popular in Cosmos at the moment. With ETH on OpenSea application and use it in my game or whatever. But again, this really doesn't have this notion of a chain specifically. And then, so that's how I want, actually us as developers to really think about what we're building. Okay, and so how does this actually work? How are we, like, what are we really relying on to really build these cross-chain applications? And I think the big benefit of using, the Evmos technology is really that we are using IBC, which is the interblockchain communication protocol, and it's basically just a standard. View it as a bridge to really transfer data safely between chains, and it's been in production in like plus 60 chains since the last 2 years, and never really. I mean, obviously there's like smaller fixes that have to be made and so on, but it's really been proven to be a very secure protocol. And even with hacks like not hacks, but like I guess downfalls of like protocols like Terra or whatever, there's like this protocol really like withstood the test of like some protocols, I guess, dying, but like still being able to run sovereign blockchains and yeah, be secured. And so the way that this works is that, I mean, if you have more questions, if you're not familiar with it, happy to like dive into it deeply, but it basically is just a way of like define like a packet data standard, and you can send it between chains, and as long as your chain adheres to the standard and you're setting up like likelines on each chain, you can like safely transport data. So this is just I think an older screenshot. There's, like I said, more than 60 chains now. They call them zones here at the moment. But this is just an example of like how many application-specific blockchains are already using IBC and are connected and transferring data. So there's a lot of potential of this omni-liquidity, this access to a lot of liquidity, instead of really thinking that it only has to be located on one chain. And so there's like, I think, 3 topics for interoperability that I want to highlight. So the first one is that if you'd start, your own chain, for example, using REVM, then you still have like this problem that you actually need to bootstrap the building blocks in DeFi, right? You have to have a DEX, you have to have some kind of notion of a stable or secured asset, have lending, things like this, that will really be able to, or allow users to actually make good financial, or like a healthy financial transaction. And that causes a lot of effort in the beginning. But if you have access, or if you have an interoperable chain, then you don't really need to bootstrap this on your own chain, but you can make use of these applications that are already deployed somewhere else. Same with liquidity. If we're all talking about TVL and seeing how like developers move to the ecosystems that have the biggest liquidity, like the idea is really that if you are adding your chain or your application in this world where interoperability is a given, then you can you have access to all this liquidity by default, and it's super important. And the third one, I mean, I already mentioned this quite a lot, is really the UX that can be enabled for end users. All right. And the thing that we're building at the moment is this thing called dynamic IBC. So I was talking about interoperability between chains and I guess users on different like IBC-enabled chains. But what we actually want to get to is really that smart contracts on different chains can talk to each other and are interoperable with each other. And this is called dynamic IBC because it's really permissionless, and you don't need like core protocol or chain upgrades to be able to add new packet types, but rather say, hey, I want to deploy my smart contract and my protocol on one chain, and I'm able to define my custom like packet type, like packet data, and be able to send that to another chain. And so that's why we call it dynamic, because it really is more flexible, or like custom and permissionless. It's not really reliant on the core protocol updates. All right, so I want to get into like 2 use cases, and the second one also will do a demo of what this means. So I think I moved one of my slides, actually. I'll get back to this one afterwards. This one is actually the next one. So what we recently did is upgrade on the FMOS chain, which really was the big first milestone for like making this deploy once used everywhere narrative a reality. And what this upgrade entailed is this thing called EVM extensions. And basically, this really enables like a shift of thinking about like having a TVL in one chain, but rather saying, hey, you have access to a bunch of other chains. And the way to think about EVM extensions is that without them, smart contracts on the EVM are really contained only to the EVM itself, right? You can talk to other smart contracts, but you cannot really break out of it or don't really have access to the core protocol level. And with EVM extensions, we actually provide an interface in Solidity that smart contract developers can use to really access core protocol functionality like staking, voting, anything really that's also custom on the core protocol, and especially IBC, which would allow smart contract developers to transfer data to other chains and vice versa. So with staking, you can build things like staking derivatives, staking managers, things like that. With voting, you could build sub-DAOs, anything really on a very permissionless level. And IBC, like I said, can be used for these cross-chain applications, or we call them IBC dApps. So now I'm getting back to this one. So the first one that we really want to showcase is this, I guess, outpost with Stride. Are you guys familiar with the Stride chain? Yeah. Okay. So Stride is basically its own chain that provides liquid staking for native Cosmos tokens. So Evmos is one of them, and right now what you can actually do is it takes a few steps. As a user, you would send your Evmos token to the Stride chain. Then you can liquid stake it there to receive a liquid staked asset, like staked Evmos, and then send it back either to Evmos or another chain to use it in a DeFi protocol. And for that, you'd have to be really connected to the Evmos chain first. Then once you have that asset on the Stride chain, you have to also create your wallet on the Stride chain and send it back, and you keep connecting and switching between the networks. And what our EVM extensions actually allow is that you can deploy an outpost contract, which is just a smart contract that users can interact with all the wallets that are supported, such as MetaMask, and then do one transaction to do this whole flow of sending the token over to the Stride chain, liquid staking it, and sending it back. And so a user just has to say, my intent is I want to liquid stake, I sign this one transaction, and voila, I'm receiving a staked asset. I'm not really even aware that this is happening on a different blockchain, right? I only need to be signed into the Evmos network. And so this is really cool from a user perspective, but even better or even more innovative, I guess the big difference here is that this service, like the liquid staking with one transaction, is also available from the smart contract level. So you could build an application that uses this almost like an API and then uses the results to do some other further action, right? Taking the liquid staked asset and deploying it in a DEX or like a liquidity pool or whatever. So this is really interesting, and from a I guess from a user's perspective, this is the normal Stride interface, and the big difference is you're not really connected to the Stride chain, but to the Evmos network, right? And you could also build, and that's what we're also going to have quite soon, like a widget on our application, where you can, as soon as you're onboarded to to Evmos, you can liquid stake your tokens with one transaction. All right. I have Vlad's post here, who's also sitting in the audience and is giggling at me, so that's kind of hilarious. But yeah, the second thing I want to show you is an outpost, and we call these outposts just maybe to explain, because in the Stride example, we don't have to redeploy the Stride protocol, right, on Evmos. It's just that one protocol is laying there. And it's not Evmos only. There can be other chains that are using this service, right? And so we say we have an outpost of Evmos on the Stride. An outpost of Stride on the Evmos zone. And so same thing I want to go into is Osmosis outpost. So what we want to go through also in the code, and I hope the Wi-Fi will be good, but we're going to try to make a transaction on mainnet where we are sending the Evmos token to the osmosis chain, performing a swap, and then this from Evmos to Osmo, and then the Osmo will be sent back to the Evmos chain in one transaction. So basically, you're just using the osmosis DEX from the Evmos chain. And that is accessible, like I said, not just from users, but also from a smart contract level. And this was also introduced in our latest upgrade. Yeah, so we're gonna try to attempt this on mainnet. So let me zoom out here. I've tried this before today already, so a backup, we'll have it here. But first of all, any questions for what I'm trying to do here? Is it clear? Okay. All right. So we're just going to look into kind of the contract that's deployed and what kind of interaction you can do there. And like I said, the goal is do one transaction to perform the swap. If I look into my assets here right now of the account that I've connected, I have like around 3 Evmos and a bit more than 1 Osmo, and we're going to attempt to like send two, sign a transaction that swaps 2 of the Evmos to the Osmo token. And so what we have here is just this outpost contract. And there's one, I've already actually loaded it into a Remix, right? You can we deployed this before at a given address, and you can load the interface into Remix, so you can just interact with the contract. And we have this one function called osmosis swap. And this basically does 2 things. One is you approve the transfer, and then the second one is you're creating an IBC transfer that is going to initiate this whole cross-chain swap. The approval is basically just approving the contract to kind of spend the amount that you want to send in general. So there's basically this approval that is happening and is also imported from the interface of the EVM extension. So if I go to this ICS20 Sol contract, for those who don't know, ICS20 is just the packet type for a normal IBC transfer. And what we basically built on the core protocol is this. This is basically the interface for the EVM extension for the IBC transfer. And so this is like a given address at which anybody can really perform IBC transfers from a smart contract, and then it'll give you the interface such as transfer and the actual and the returns, and the actual logic is deployed on the core protocol. And so first, basically, we're just running through an approval of the amount that we actually want to transfer, and then we compose the actual transfer transaction or message, I guess. And the way that this works is that the normal ICS20 packet just has the denomination that you want to send, the amount, as well as this additional thing called a memo field. And this memo field can be, I guess, misused a little bit to really include all the information that would be required to do this cross-chain transfer. So on the osmosis side, what they've actually provided is this almost like a middleware that understands or parses this memo once the IBC transfer arrives, performs the swap and sends it back. And so this memo is then also included in this ICS20 transfer. And all of this is basically one function that you can call, which is the osmosis swap. So hope it's big enough. So if you are interested in actually doing this yourself, then you can also follow this tweet, right? So I'm gonna shout you out, Vlad, because all of this information is really explained here with like the extensions repo. This also includes the Outpost contract that we just looked into, as well as the dependencies or the imports here of like the EVM extension interfaces, which are also in this repo. Just note that I think by default it is connected to testnet, so you might have to actually change the addresses if you're working on mainnet. But all of this is also described in the thread. So let's do it. Let's try to actually perform this this cross-chain swap. So just confirming that I'm using the right things here. So basically, the inputs that this function requires is the amount, right? The base denomination that you want to send, and the one that you want to receive from the swap, as well as the receiver account. So we want to get the Osmo back at a specific given address, right? And so we have like two evmos here. You have obviously like the ADO evmos just to provide the right denomination, and we want to get Osmo back. And this address is, I believe, my yeah, like we basically have two representations. If you're not familiar with this, but this is the classic hex address that you know from Ethereum, and this one is more from a Cosmos ecosystem, which is BEC32. But yeah, I believe you can also provide both. Yeah. So yeah, we want to perform this transfer. Let me just collapse this last one and do a cross-chain swap. So we're going to have the like MetaMask connected here with injected provider. So make sure to actually do that before. Pay the gas fees. And then it's going to actually approve, right? And it's going to send the IBC transfer. And okay, the Wi-Fi worked. I'm happy about this. So if we look into this a bit more in detail, maybe make it a bit bigger, it gives me, the address that I interacted from and the contract address that I interacted with. And most importantly, it gives me the logs, which are the transfer authorization for the IBC transfer, as well as the IBC transfer itself, right? I can also look into this on eScan, which is our block explorer. So if I'd go to this latest contract interaction, I can view it on the block explorer, where you have a bit more nicer interface, I guess, also of the logs, and see exactly what's happening here. And this block explorer is cool because it also, actually lists the EVM extension that you're interacting with. So yeah, we hopefully have 2 evmos less. So let's see, and some more Osmo received afterwards. Okay. So if you remember, it was at 1.2 something, right? So we actually did a cross-chain swap, which is pretty cool. And if for the more visual people, if we actually go to the Osmosis interface, which hopefully loads, we'll wait, we'll see. Usually, like I said, I think the important part is that this is, accessible for users, right? But even more important from the smart contract level. This is really what we're focusing on. So yeah, we just did a cross-chain swap on mainnet, which is amazing. And you could say like, hey, I want to actually, I don't know, swap 1,000 evmos, get Osmo back, and then use the result to provide liquidity on a DEX on evmos, for example, or on another chain, or even on Osmosis. So that's kind of the idea of this Osmosis outpost. Any questions? Okay. Did this one load? No. Let me check if I can show anything else here. I guess in the Block Explorer, if I refresh this, what we do see is this is the contract that we interacted with. So 2 minutes ago, right, we did this interaction. So it's all already here. And if I'd go to my wallet, I should also be able to see the incoming IBC transfer. So as soon as you actually swap on Osmosis, you will actually, there's a second IBC transfer that's initiated to send back the Osmo token to the Evmos chain. And so you can also see that this actually is captured in the logs and also displayed here in the Block Explorer. All right. Cool. So jumping back into here. Yeah, if you wanted to try this at home, you can do this on mainnet or on testnet. There's both is possible. I like to do it on mainnet because there's a bit more of a rush happening, you know. So where does this all lead us or bring us to? I was talking about, yeah, you want to provide like applications to end users, right? And the one way that our team is really thinking about it is we want to provide, you know, an interface where users can do this in a really simple way, and where developers can also understand that, like, hey, this can be really easy, and I also want to build my application the same way, or use this like cross-chain connectivity or interoperability to, yeah, not have to bootstrap my DeFi, not have to worry about liquidity on my specific chain, things like this. And at the moment, this is our, you know, our normal like app.evmos.org interface, but what you'll see quite soon is that this will be also replaced with like basically like more widgets, more like call to action things where users can directly use these protocols, right? You just connect your wallet to this interface, and you can already like liquid stake. You can cross-chain swap on Evmos, on Osmosis. You can do all these things, and developers can also build like more, I guess, advanced strategies and offer them to users. So that's really our, I guess, our end goal, and that's what we're working on at the moment, and will be really exciting to see people use. Just zooming out, like, I guess when I give this workshop or this talk, I really try to not talk about Cosmos too much, because I feel the Ethereum world is really still like so much bigger, and for us, really we're really like a port of entry for this kind of world, and yeah, EVM developers exploring what other technology there is, right? And it doesn't really matter so much in the first place that there's, you know, that I guess our chain is also built on the Cosmos ecosystem. But the important part is really that we're like leveraging this technology to really have the ability to use IBC in a really like standardized way. But just still, like, there's actually, if you account for all the liquidity in TVL in the Cosmos ecosystem, it amounts to almost, I think this was at a time like $1 billion a month ago or something, $1 billion. And yeah, we are also seeing already more Ethereum, like layer 2 applications also trying to adapt IBC, and there's a lot of big interest there. So we really see that that's going to be like the future. So just remember, deploy once, use everywhere. And thank you for listening. And if you have any questions, happy to answer. Anybody? No worries. I'm also around. Happy to talk about anything. And yeah, enjoy your day. Thank you.